Okay, I just wanted to go over how I've been controlling games with the theremin. And I wanted to do a little bit of a demo of how I write the scripts for that. Here is a pretty empty script right now that I was working on for Breakout. So yeah, right now it's pretty simple. We're importing the libraries we're going to use. For these first two are both used for sending input to other programs, basically. So you can be like, click here, or like move the mouse here, press this key, and I'll demonstrate that later. And then MIDI is a MIDI library for Python that lets you read the MIDI messages coming out of the theremin. So yeah, these are really the two main things I'm using. So yeah, obviously this is pretty simple so far. We're getting the MIDI port open, which I only have one MIDI thing connected right now, which is the theremin, so it'll just default to that. I could specify what device to use if I had more right now. And then yeah, we just loop over the messages coming in, and I will... Right, so you can see there's these control change messages. There's control change, and the two important things for what we're doing is that control and value. I'm just going to copy and paste a bit so we can look at it without it moving. Okay, so yeah, control change is a particular type of MIDI message. There are different ones. Like for example, on the piano, if you press a note, that's note on, I believe. The theremin doesn't output note MIDI messages. It's only control changes, which is fine for controlling a game. It doesn't really matter. Right, so yeah, the two important things are this control number and this value. So you can see right now there's three different control numbers. There's 2, there's 20, and there's 52. So we can talk about 2 first. Control number 2 corresponds to the volume antenna on the theremin. That's the one on the left that's kind of like flat going out to the side. It's not the tall one. And you can configure the theremin to have different output ranges. So for the volume antenna, I just have it using 7-bit MIDI control messages. So what that means is there are 2 to the 7th possible output values, and specifically it's 0 to 127. So you can see that this is at 125. So for the volume antenna, if you get closer to it, the number gets lower. So the number here is pretty high because I'm over at my computer. I'm not right by the theremin. So this means I'm pretty far away, but close enough for it to register something. I think I probably waved my hand over at it. Okay, right. So that's that's one of them, and that's the simpler one. Right. Then we have these other control numbers, right? So we have 20, 20, 52. So yeah, the way this works is I have the pitch antenna configured to use 14-bit MIDI. So that has 2 to the 14. That's 0 to... I don't know. I forget the exact number. It's something like 16,000. It's a little bit more than that. So you'll notice that there's 2 different numbers here, right? And the reason for this is that for like backwards compatibility reason, you can only actually send 7-bit values in control change messages. So what they did, there's kind of a standard that you send the higher bits over a lower control number. Then you add 32 to the control number. So 20 plus 32 is 52. And you send the lower, also called the fine bits, over this higher channel. And then you just have to basically combine the results. Let's say we got in binary 0, 1, 1, 1, 5, 6, 7. Sure. And then on 52, let's say we got 2, 3, 4, 5, 6. Right. So to get the combined thing, we would say that, okay, this is the higher bits, the more significant bits, and this is the lower bits. So let's just interpret this as a binary number, and look, say it's 8,065. Sure. Right. So basically the program will have to combine these two numbers. Obviously, if they're both 0, it's going to be 0. But I already have that code written, so that's sort of not really yeah, here it is. So it's basically this. So that's not really an issue. So I think I might have mentioned the theremin is configurable, so you can have it be 7-bit or 14-bit for either one. I have 14 bits on the pitch antenna right now because at least for Pagel, it was a lot more precise. So I thought that was worth doing. There's some other games, like Doom, for example, where I don't know that it made a huge difference, but it's not doing any harm to have more precision there. So I think that's fine. Right, okay, so I can show some other stuff, I guess. So I mentioned all this stuff. So for now, let's look at the volume antenna. So let's say if message dot control equals 2, this is the volume. Here, for now, let's just print the message. Right. And like I mentioned, if I get closer to it, I'm close to it now, it gets a low value. If I get further away, the value increases. Yeah. So let's have it press a key when the input is below a certain amount. So let's say if message dot value is less than 50, let's have it press a key. So pi. Let's just press A for now. Just have an example. Right. So A. Okay, see, I put my hand by the volume antenna. The number went down. We pressed A. Okay, yeah. Okay, so this is the more or less finished Breakout program. Just wanted to go through it, do some explanation of what it's doing. So basically, here we have handling for finding the ball. I had to add in a timeout, pressing spacebar, which fires the ball, because otherwise it would spam spacebar when your hand was close to the volume antenna. And in some games that wouldn't affect anything, but in Atari 2600 Breakout, it does not like that, and it makes it so you can't move the paddle back and forth, which makes it very hard to hit the ball right after you fire. So I had to add that. But yeah, you can see the actual code to press space is pretty simple. So yeah, here we're just setting the bits for the position, and we get it as a fraction. We're reducing the precision because it helps with the performance. So we have this pause state. This is just mainly helpful for debugging and stuff. If the program keeps trying to move the mouse, it makes it hard to exit the program. So I have it so if I touch the pitch antenna, the program will basically pause and stop moving the mouse, and then I can go exit it or whatever. Yeah, and then the other interesting bit is up here. So there is a queue. The reason for this is it takes time to move the mouse, and basically if the main thread that's reading the MIDI messages tries to move the mouse, it gets more and more behind the current MIDI messages because the theremin actually sends a lot of MIDI messages. It's something like 40 a second based on some rough math I did. So what we're basically doing is we're writing to the queue down here, and then we read from the queue. We have this count system. So basically we want to prioritize the latest movement, and it's okay if we skip old movement. If I move to the left and then I move to the right and it can't catch up to me moving to the left, I just want it to move to the right, basically. And then here's the math for moving the paddle. Some of these numbers are a little bit arbitrary. I was just experimenting and did some numbers that worked okay. The reason it's not going just with the fraction from 0 to 1 is because the game doesn't actually take up the full width of the window. So there was kind of a dead zone on either end where moving in there didn't actually do anything. The paddle would just be stuck up against the edge of the gameplay area. And then of course here is the place where we actually move the mouse. Again, that's like pretty simple. Yeah, so that's pretty much it. I am planning to post all of this code on GitHub. So I'm going to put a link, I think, in the description or a pinned comment. Okay, I think I have Breakout pretty much working. It took some tweaking. I think it is pretty much working. Yeah. But it turns out I am not that great at Atari Breakout, but that's okay. Gotta enjoy the sound effects. They're very, very crunchy. But yeah, you can see it works. Controlling the position of the pitch antenna is over here, and then I can launch the ball by going close to the volume antenna. Yeah, and then I'll sort of go over the finished program and talk through it a bit and explain how I do stuff. Yeah, should be cool. Guess I'll keep going until I die. I suspect it was not going to take super long, but we'll see. That's too much sideways velocity, making me a little nervous. Oh god, going so fast. Okay. Wait, do I have an... Oh, I do have another log. Okay, cool. Yeah, so that's Breakout.